Welcome to NASA's Jet Propulsion Laboratory in Southern California. NASA's Ingenuity Mars helicopter made history this month with the first powered, controlled flight on another planet. Today, we will learn what Ingenuity's next steps are after successfully completing 3 test flights on Mars. I'm your host, Raquel Villanueva. To talk about the helicopter's upcoming plans are Lori Glaze, Director of NASA's Planetary Science Division, Aung, Ingenuity Project Manager, Bob Balaram, Ingenuity Chief Engineer, Jennifer Trosper, Perseverance Mars Rover Deputy Project Manager, and Ken Farley, Perseverance Project Scientist. For anyone watching who would like to submit a question, you can do so by using the Mars Helicopter hashtag. Our phone lines are now open to the media. You can ask a question by pressing *1 and enter the queue. To talk about the goals Ingenuity has met, I'd like to welcome Lori Glaze.
Hi, thank you so much, Raquel. I want to start off by congratulating the amazing Ingenuity team. They have achieved the unbelievable and inspired the next generation of explorers with their Wright brothers moment last week. I also really want to thank the Perseverance team for their incredible support of this month of Ingenuity. The videos of Ingenuity flying on Mars that Perseverance has captured and shared with the world are truly spectacular. And the Ingenuity technology demonstration is a huge success. They've done an amazing job, and they've met all 3 of the goals that NASA set at the outset. The first goal, of course, was to demonstrate back here on Earth, before we ever even launched, to demonstrate that it was possible for an aircraft to actually fly, a rotorcraft could fly in that very thin, low-density atmosphere environment of Mars. And they demonstrated that in a Mars chamber back at JPL before we ever even launched. So that was the first goal. The second goal was to show that we could actually fly on Mars, to do that powered and controlled flight on Mars. And that was completed in the early morning on Monday, April 19th. And then the third requirement is to not just fly, but to return the critical flight data back to Earth, transfer it through Perseverance back to Earth so that we can study and analyze those data and help us plan for the aerial systems of the future. And if you could show the video now, please. I'd just like to share this one with you.
Data products. You can see AVRs are looking nominal. We see Z going to 5 meters, and then in the y-axis, which is relative to the starting position, we see the helicopter going out to 50 meters and coming back again.
Of course, was the helicopter operations room as they celebrated mission success, as they received the data from flight number 3, where they confirmed the last major objective of the mission to fly 50 meters downrange and back again. Technology demonstrations like Ingenuity are really, really important. You may recall NASA's first mobile surface explorer, the Sojourner rover, launched in 1997 and completely shifted our paradigm, forever changing how we think about exploring the surface of Mars. And Ingenuity is going to do the same thing. We've learned so much from this little technology demonstration that will enable future aerial systems and explorers. I also want to give a quick shout out to the MOXIE technology demonstration on Perseverance that also had a major success last week when they successfully converted the carbon dioxide from the Mars atmosphere into oxygen, which has major implications for future human exploration of Mars. With the success of these amazing technology demonstrations, it's now time to pivot and start Perseverance's sampling campaign as the rover starts to head south. And Ken's going to be talking in a few minutes about the exciting science plans for the coming weeks. I'm also very excited to announce that after assessing the Perseverance science strategy, there's room to expand the Ingenuity demonstration into a new phase. What you'll hear about today from Mimi, Bob, Jennifer, and Ken is how Ingenuity is going to transition from a technology demonstration where we proved the technical capabilities of the helicopter to an operations demonstration where we're going to gather information on the operational support capability of the helicopter while Perseverance focuses on its science mission. So what I'd like to do is hand it over to Mimi to talk about where we are today, what this transition is going to look like, and what we're hoping to achieve during the Ingenuity operations demonstration.
Thank you, Lori. We truly appreciate the opportunity that NASA has given us for Ingenuity to now enter a new phase, operational demonstration phase. Our team has been extremely happy and proud of the Ingenuity's flight to date, and now it's like Ingenuity is graduating from the tech demo phase to now the new ops demo phase, where we can show how a rotorcraft can be used and show products that only an aerial platform from an aerial dimension can give. If we can play the video. This is a video of our flight number 3. And through these flights that we've had, we've been able to conclusively confirm our models and simulations and tests that we've done on the Earth. And in this flight here, there's Ingenuity flying free. It's finally flying 50 meters out. In fact, so far, it got out of the field of view of Mastcam-Z that's very carefully videotaping the flight. And it was a joyous moment for our team because, you know, the Ingenuity had only been flying in chambers and constrained volumes until now, but there it went. And it does come back into the field of view of Mastcam-Z camera. And that was a fantastic day. So there was Ingenuity flying free, and with that, we have met all of our technical goals early in our first 3 flights. We're very happy. In addition, we've captured images from this first ever aerial images taken at Mars. Next, please. First from our engineering camera, the black and white camera that we use for engineering. Here's one of our favorite black and white pictures. And icing on the cake, we've been able to also capture color images. And here is one of them. In fact, in the top left corner, we caught a glimpse of Perseverance rover. So, you know, with this new phase, we will now concentrate on utility of an aerial platform and work on operational products, such as aerial observation of specific science targets or looking at context features from places that are not accessible by rovers. Another operational product we'll look at is scouting for potential science observations, scouting for future rover traverse, or scouting for new airfields for the helicopter to transfer to. We can also look at stereo imaging of digital elevation maps. So as we make these products and the lessons learned from that exercise will benefit future missions with aerial platforms tremendously, definitely feed forward. And as we pursue these operational products, we will also continue to push the capability of Ingenuity. So a little more on the timing. This is a 30-day operational demonstration phase, but also note that Ingenuity was built and tested for the original 30 days of technology demonstration flights. So we will be celebrating each day that Ingenuity survives and operates beyond the original window as we enter into this operational demo phase. So at this time, Ingenuity remains healthy, and we will try our flight number 4 again today. And flight number 4, in fact, takes the first step into the operational demonstration phase. Flight 4, we will attempt the scouting functionality. Ingenuity will fly 133 meters south and take 60 black and white engineering camera images and 5 color images. And Ingenuity will fly back to the current Wright brothers field. And after landing, we will make 3-dimensional digital elevation maps with the engineering images, and then we'll use the 3D digital elevation maps and the color images to pick safest new airfield that we can see. And on Flight 5, we will send Ingenuity on a one-way flight to transfer to the new airfield. And after it arrives at the new airfield, we're going to work very closely with Jennifer's and Ken's teams to identify the new operational products and scenarios that we want to test forward. So I can't tell you how excited we're about this new phase. And I want to thank Ken Farley. Ken, thank you for the first 30 sols. Really, the precious days on Mars, that really allowed us to show that we can design and build and operate a rotorcraft for Mars and this opportunity to continue forward. And Jennifer, thank you for the Perseverance operations team, all the imaging, the video coverage, and your team absolutely coddled Ingenuity to give it all the chance that it could possibly have to succeed. So really looking forward to continuing. So we are now, we can only think of this ops demo phase because of how well Ingenuity is operating, the stellar performance it has had to date. And so I'll turn it over to Bob to discuss it. Now, Bob is our chief engineer and innovator of Ingenuity's original design. Bob, you shepherded this design through making sure it fits in this 1.8 kilogram through its entire journey. And I can express how impressive it is that Ingenuity today looks almost exactly like the Ingenuity initial concept that was sketched in 2013. So, Bob, congratulations for your vision coming into fruition to reality. So, over to you, Bob.
Thank you, Mimi, and thank you for your fantastic project leadership, and thank you, Perseverance folks, for really just getting us through to this point. So, it's been great just watching Ingenuity, take flight in those Martian skies. As Mimi said, we put it in various torture chambers here, tethered and little metal boxes and, all kinds of gadgets connected to it. And to see it fly freely in that thin Martian atmosphere in that Jezero crater area is just fantastic. Now, I've been watching that video, the same video that you guys have been watching, over and over again, and it's just it plays peekaboo going off the screen, and then it comes back, and every time I just love it. But, there's a lot of engineering performance that's fantastic also on this vehicle. What you may not realize is in that flight where we traveled that far and came back, Ingenuity knew where it was on the surface of Mars to within 5 centimeters. That's 2 inches. It knew exactly where it was when it descended to land, and it landed within a foot. It's been there, it's been riding the winds, it's been taking off great, it's been everything's working very well, all the engineering systems, the solar panel, the battery, the radio, all the avionics, the computers, everything just going fantastic. And so I wanted to just draw attention to sort of some of the flight performance. So could I have my first slide, please? What you see on this slide is what Ingenuity sees with its camera looking down on the ground, and that's that image on the left. And what you will see as we play the animation in a little bit is you will see the features that Ingenuity is tracking on the ground, which then it combines with inertial sensors, and it achieves those kinds of accuracies. Now, this data is from Flight 2, where it's particularly easy to see all of this performance. And there are 3 plots that will animate. The first one shows the position. And you can see that we'll see that the altitude is held to within 1 centimeter. So that's a great performance from the altimeter and the flight control system that's keeping that. And the positions, as we are fighting in the wind, and sort of surfing or riding the wind, is within 25 centimeters. That's less than a foot. The second plot you'll see is the velocities as the system is going, forward and back. And the third plot shows the heading, how well are we pointed? And we have incredible pointing, like it's 1.5 degrees. In fact, some of the imaging folks have been taking some of our images and overlaying them. They haven't had to do much in the way of correction because the initial pointing information we give to them is just perfect. So all in all, it's really a great, well-performing vehicle. And now if we can roll the animation, you can see what Ingenuity sees. As it takes off, all the green features are what it likes. Red features are what it's rejecting as being outliers. And you can see that every time the vehicle, as it approaches a turn, you'll see all the features sort of spiral out. And it's just great watching this. This is the hardcore engineering data that lets us validate our models. So when we go off to design the future helicopter, we have a solid basis of data that we have confidence in. We know that things worked. And there's a treasure trove of this data that really allows us to finish this technology demonstration phase and take on the opportunities to go to other aspects of the mission, which is us to serve as a scout, to be explorers. And so again, I want to thank the Perseverance team and everybody at NASA for that opportunity for us to showcase this next phase of the mission. Thank you.
Well, thanks, Bob.
And Jennifer,
Thanks, and congratulations again to you and Mimi and the whole Ingenuity team for just a fantastic tech demo. It's been a great month of Ingenuity. Can I see my first slide here? I think Perseverance has enjoyed having a little buddy there on the surface. This is our selfie. I call it our vacation photo of Perseverance and Ingenuity sitting there together on Mars. And Perseverance over this month has really just been focused on supporting Perseverance, or Ingenuity. And what it does to support it is it transmits the data back and forth for Ingenuity. And it also, as you can see from a lot of the images that we've shown, is a pretty good photographer of the Ingenuity flights. And now that the tech demo has been just amazingly successful, we are transitioning and pivoting to focusing more back on our science mission. We will do that over flights 4 and 5. Mimi talked about how the helicopter is starting to look at areas of interest to the rover. And then after flight 5, we will actually begin the set of activities that we need to complete on Perseverance in order to enable sampling. So some folks may wonder why we are doing this operational demo. We had not originally planned to do this operational demo with the helicopter. But a few things have happened that really have enabled us to do it. The first thing is that originally we thought that we would be driving away from the location that we landed at. But that's not true. The science team is actually very interested in getting the initial samples from this region that we're in right now, and Ken Farley will talk to you about that. Another thing that's happened, and you heard about it from Bob and Mimi, the helicopter is operating in a fantastic way such that even the communications link has a lot of margin, is overperforming, and so even if we move further away from it, we believe that the rover and the helicopter will still have strong communications, and we'll be able to continue this operational demo. But in order to make the operational demo not have a big impact on the science mission, in fact, we call it not to interfere, we have to operate Ingenuity slightly differently than we did before. What that means, this new paradigm of operations, means Ingenuity will only fly every few weeks instead of every few sols. We leave it open a little bit because it depends on what Perseverance is doing as to where we want to fit in the Ingenuity flights. Another thing, and Mimi talked about this, is Ingenuity is scouting for its own landing sites. Perseverance is not taking imaging, in fact, can't even get imaging of the areas Ingenuity is now going to go land in. And then the final thing is Ingenuity will be sending down those images from her flights through the rover, and we'll do this for 30 sols, and we'll see how it goes. The reason we're doing this is because, as you can see from those images, that a future mission that wants to integrate aerial reconnaissance into the mission scenario, we can inform how to design the helicopter, how to design the mission scenario, how to design this mission to be very effective by taking these products that Mimi talked about. We'll take color images, we'll take stereo products, we'll take them from different vantage points, we'll take them of different areas that the rover can't get, and we'll have a lot of information that these future missions can use for design requirements and scenario planning. And I'm very excited about doing that and continuing to work with Mimi and Bob and their team. What a great team, the Ingenuity team and the Perseverance team. We've just had a lot of fun doing this tech demo. And I'm also super excited about releasing the new set of capabilities that we need in order to get to a sampling capability on Perseverance. So what does that mean? What do we need to do in order to get our first sample? We have 3 major areas of capability that we're still working on getting released on Perseverance. The first one is that we need to upgrade our driving capability. So if you bring up my next graphic, this graphic shows, and all of you know, we have been driving. The white lines are our drives The blue is the helicopter airfield, and you can see the picture of the rover where the rover is now. But we've been using just our rudimentary drive capability. To get into more difficult terrains, we have to do something, we have to use our visual odometry capability. Visual odometry is where we use the images from the navigation cameras and we compare them as we drive and make sure that we're making the progress that we expect, that we're not digging into the dirt or slipping. So we should have that released shortly, and that will help us traverse in more hazardous terrains. And then we have an auto navigation capability where the rover will autonomously drive. We have 4 or 5 activities that we need to do in order to characterize and release that. And once that is released, Perseverance will be able to drive up to 3 times further on any given sol than Curiosity ever did. So it's a great capability. So that's one set of capabilities. The next set of capabilities are the proximity science capabilities. So proximity science, the instruments and the camera on the end of the robotic arm. We've obviously been using those. We used them to take the selfie. We've been taking images of the surface of Mars from a standoff of about 10 centimeters, but we need to get much closer. We need to get to about 2 centimeters. So we have a set of activities to calibrate and characterize our ability to get within that 2 centimeters on the surface. And then finally, we also need to finish our checkout of the sampling system itself. The adaptive caching assembly, which sits in the front of the rover, and the sample handling arm, which manipulates the sample tubes, still needs to complete its checkouts, which we'll be doing the last few weeks of May. So when we finish all of that, we will have a full sampling capability where we can quickly get to the locations the science team wants to explore. We'll be able to investigate what rocks are best for sampling with our instrument suite on the end of the arm. And then we'll be able to actually sample and get a sample. So with that, I will hand it over to our project scientist, Ken Farley, who will talk a little bit about where we think these first samples will come from. Ken?
Thanks, Jennifer. On behalf of the science team, I'd also like to offer my congratulations to the Ingenuity team. It has been a very fun ride for the science team to be supporting Heli and to really have the front row seats of watching this really remarkable technology demonstration succeed. Beyond that, it has been a very busy time for the science team. The last 2 months, we have gotten an enormous amount done. Jennifer has told you about the checkout of capabilities that are now completed on the rover and that will continue for a short amount of time going forward. But really, this is the time that we are transitioning into the science mission. We have acquired enough information from the instruments already, literally thousands of images, which are now up on the NASA websites. You can all go and look at. And this information has told us a lot about our landing site. And this has allowed us to prepare a plan for how we will proceed. And as Jennifer mentioned, what we are going to be doing is an intensive investigation, which we call a scientific campaign in the region. If I can have the first graphic, in the region in this red bounded zone. For reference here, the Perseverance rover is at the blue dot, and the distance, the diagonal distance of that red zone is a little over a mile. So we are expecting to explore in this area, looking for interesting rocks. What we believe we will find in this area are rocks that likely represent the oldest material which is present in the crater floor, and that's the very heavily cratered area on the eastern side of the previous image. And the exploration that we will do will also bring us to what we think are likely to be rocks that were deposited in the middle of the lake that once filled Jezero Crater. These rocks are likely to be mudstones, very fine-grained, once mud at the bottom of the lake. And these are very important for our investigation because this is the kind of environment that we expect to be most habitable by organisms that might have existed on Mars billions of years ago, as well as having the capability to preserve biosignatures over the billions of years since the lake dried, climate changed and the lake dried. So that is the plan for the next probably several hundred sols. We expect to collect a small number of samples, perhaps 3 or 4 samples in this time period. And then we are likely to move off towards the delta. And what you see in this image here is an indication of the terrain in that red zone. And what the important features, you can see the rover tracks, you can see we're going to backtrack a little bit past where we initially landed, which is only something like 100 meters away from where we are. And we will trek something like a mile. And one of the very fortuitous things is the location that we landed actually involves multiple different rocks exposed at the surface, as well as a safe and straightforward pathway for traversing. We have quite a narrow corridor actually that we can drive through. On the one side we have sand dunes that are too risky to drive through, and the other we have boulders, and we have this nice corridor that is going to direct us into this area where we will undertake our first campaign and really get the science mission started. This is of course a multi-year scientific investigation, but we're very excited to be getting this first step going. And the other thing I like to say is it is very interesting for us on the science side to be able to participate in this demonstration of the operational capability of a helicopter. Of course, we recognize that the ability to both scout rover traverse directions, making sure that there are pathways that are safe and efficient to get us to where we want to go, and the ability to fly the helicopter out into terrain that the rover cannot possibly traverse to bring back scientific data. This is extremely important for future missions that could combine a rover with a reconnaissance helicopter. And so the science team is excited about being able to play its part in further supporting this demonstration for Ingenuity. And with that, I will turn it back to JPL and Raquel.
Thanks, Ken. We are now ready to take media questions. Remember to press *1 to get put in the queue, and please direct your questions to one of the panelists. We're also taking questions through the Mars helicopter hashtag. To start, we have Marcia Dunn from the Associated Press.
If Flight 4 takes off today as planned, when will Flight 5 be? And am I correct in understanding that the helicopter is going to have 30 sols on top of the first 30 sols for operations, which would take potential flights into the beginning of June? And how far can these two vehicles be apart and still be able to communicate? And will the new airfields be along the rover's path? Thank you.
I can start. Yes. So first, yes, is 30 sols beyond the initial 30 sols. So and the vehicles can be apart up to 1 kilometer or even further. As Bob mentioned, the signal-to-noise ratio is extremely good. So we can go even beyond 1 kilometer distance. So in terms of Flight 4, and then the timing to Flight 5. Flight 4 is, first of all, bold. Okay, it's going to be a 266 meters round trip. And then after it lands, we are going to be processing these 60 black and white images to generate these 3-dimensional digital elevation maps. And then based on that, make the decision on where Flight 5 will go. So the timing between Flight 4 and 5 will be longer than usual. Instead of the 3-day cadence, it will be close to another week before we attempt Flight 5.
Thanks. Marcia, you had several questions. Did you have another one you'd like to get answered?
Let me just, I'm sorry, I've got all this, I got to mute my audio. I think that answers it. So you'll be having tests through June. Oh, and will the flight path, will you be sort of trying to find airfields along the route of the rover, or will the rover sort of be trying to tag along where the helicopter is going? Who's leading who here? Thank you.
Oh, absolutely. The rover is primary going forward. So yes, we'll be working with Jennifer and Ken extremely closely. And in fact, not just even the path, even the kinds of products that we want to prioritize. So yes, definitely a shift from our 30 days of being spoiled, Jennifer, to now, yes, we will be on, working with the convenience of the rover.
Thank you, Mimi. Up next, we have Kenneth Chang with the New York Times.
didn't enter flight mode. I understand that from testing, it didn't. Your fix that you had didn't work about 15% of the time. I was just wondering what sort of conditions lead you not to enter flight mode. And I was also wondering, there's talk about trying to get sound of the helicopter. I was wondering what the status of that was. Thank you.
I'm not sure I heard the question. It was a little chopped up there.
Oh, sure. Kenneth, could you repeat your question, please?
Oh, sure. Yesterday's attempt to do the flight didn't enter flight mode. From ground testing, I know about 15% of the time your fix that you had did not work. I was wondering what were the specifics of the conditions that lead it not to work. And I was also wondering what the status was of trying to get sound of the helicopter.
Yeah, let me talk to the going into flight mode question. So we had a choice of two, possible ways to fix it. One was a software fix, which would have taken a little bit longer to get onto the aircraft. And the other one was this sort of little bit of a random touching of the registers, if you will, that would flip the mode, good 80% of the time. We chose that path because it was the most expedient path and it didn't disturb the existing software, which otherwise has been doing extremely well. And it's just a matter of timing. There is a bug, that this is a workaround for the bug. And we're exploiting some slight idiosyncrasies in the timing of the way the computers talk to each other to sort of fool the system into being okay and accepting the transition to flight mode. So that was the sort of the trick. It worked out perfectly well, 3 times. And yesterday it didn't quite work, and we'll see today whether we got past that little block. But it was a known way of doing it, and it was quite successful, so we're quite happy with it. But as this days proceed, we might choose to get the more permanent fix into the system, so we don't have to play this dice game every time we try to fly. And then there was a second part of that question, which I've forgotten.
About the status of getting sound. Do you want to talk about that, Jennifer? He's saying, what is the status of getting sound from the flight?
Yeah, I can just briefly say, we did a characterization test earlier in the week where we were running the cameras and the SuperCam microphone and the radios, and that worked. So we are going to attempt to get sound from flight number 4.
Okay, thank you. And up next, we have Paul Brinkman from United Press International.
And all systems are functioning well. I was wondering if you could just talk about your best estimate right now as to how long Ingenuity could remain functional in this, given what you've learned.
Yeah. Let me take that one. So right now, Ingenuity is healthy, but it wasn't really designed for a long mission. So all the parts that are there in the system have not gone through a validation of, how many freeze and thaw cycles they can go through before something breaks. The number of commercial parts which were not explicitly designed for the space environment. So the expectation is that at some point, with enough thermal cycling, something will, a solder joint or something will snap. But that said, there are no consumables on this helicopter. The only consumable, if you will, is our landing gear, which is probably good up to 100 landings. And as you can be seeing in all the videos, we really haven't been stressing the landing gear at all. Everything else is just a function of, energy availability. There is dust in the atmosphere that will build up as the months progress, but right now is a good time to fly, and we'll probably be good from an energy perspective, at least for a few months. And if the luck holds out as far as the parts go, we should survive all those freeze-thaw cycles and be okay.
Thank you, Bob. And we have a social media question coming in. It's on Twitter from Headcrab Zombie. Asks, 3 flights so far. What has been your biggest surprise?
Well, I think the surprise has been on the positive aspect. The data that we're seeing, what Bob showed, and to quote, some of the team members directly, it's been just phenomenal. Just the currents and the voltages and, and the flight performance have been exactly the way we have seen in our tests here on Earth. And that is Bob, when you say that is a super surprise, because we've planned on the first 3 flights with the 2 contingency flights to make up for surprises and differences, in our models, any unknowns that we would have had, and that's what those extra 2 flights for, and we have not had to use it. We've been able to wrap up in 3 flights.
Yeah, I think technical performance has been fantastic, and that is, exceeding all our expectations. I think we had in our mind that there would be some issues on that level, and we'd have to work with them. But the only issue we had was the little gremlin that prevented us from going into flight mode. And in a way, that it was very satisfying to see all of this great performance come after we sort of got past that hiccup. So it's the other thing that I think surprised me a little bit is that we're actually getting very good visibility into what's happening inside the helicopter. I mean, we knew we planned it and we designed for it, but I always had this fear that we'd get to Mars and not be able to get all the data we wanted and not get that visibility into what's happening. We get a lot of visibility here when we test here on Earth because we're highly instrumented in our test chambers. But thanks to Perseverance's videos, thanks to the sheer data volume that they're able to process through all the orbiters back to Earth, we're getting so much data, and that's been a very pleasant surprise that essentially everything we've asked for from an engineering sense, all the data we've been getting, the performance has been superb. And all the contingencies we worried about, not surviving the night, not having enough energy, solar panels, perhaps not working as well as expected, all of those things have just gone away, and it's been working exceedingly well.
Great, and up next, we have Bill Harwood from CBS News.
Yeah, hi guys. The 30-day op demo that you're getting ready to embark upon, is that a firm line in the sand? In other words, if you're still fully operational, is there any chance that you could extend farther, or will that be it? And when you get to the end of that 30 days, or wherever the end comes, what's your plan for the helicopter? Do you park it somewhere and Perseverance drives away, or is there anything else you could do? Thanks.
Lori, do you want to answer part of that question?
Sure, I'd like to take part of it. Hi, Bill. Thank you for the question. So we're, as a demonstration in the operational demo mode that we're going to move into after the 4th and 5th flight, we're in a kind of see how it goes phase. So we're going to watch the performance. We're going to see the kind of data products that we can get back and see how the 2 flight systems work with each other. With Perseverance taking the lead and being very focused on its science. And after that 30-sol period, we'll assess where we are. We'll see where we are. We'll check on the health of the helicopter. We'll see how, if it's being helpful to Perseverance, or if there are impacts to the ability of Perseverance to do its core science jobs. And we'll assess the whole picture and see where we are at that time. So there is a potential to go beyond, but we'll have to assess it after 30 days. And then, I don't know if Jennifer or Mimi want to take the second half of the question.
Go ahead, Mimi, if you want.
Oh, absolutely. I think we gauge as we go. Again, a reminder, Ingenuity was built and tested for 30 days of operation. So I think, as Bob reminded, we really do expect some finite life. And so it'll be a race, between how long these parts surprise us in surviving. And also in doing these operational scenarios, we will naturally be pushing the limits of Ingenuity. We will be flying over unsurveyed terrains, and over time, continuing to transfer to airfields that are not well characterized. So there's a higher probability of bad landing. So, definitely we see how we go forward.
Yeah, and I'll just add, there are lots of different ideas about how this might end and what the final flight might be, and we've all talked about it many times. But as we go through, our objective here is just to evaluate every month and see how it's going, and then determine what the next steps are. So we're not really ready to say what the final step would be, because we're taking it incrementally at this point.
Thanks for your answers. Up next, we have Lisa Grossman with Science News.
Hi, all. Thank you for taking my question. This is probably for Mimi. I was wondering if you could anthropomorphize the helicopter a little bit. Now that you've gotten to know it, does it have a personality? What's its relationship with Perseverance like? And if you were Ingenuity, how do you think you'd feel at this moment?
Wow. Okay. So Ingenuity, my summary, Ingenuity loves Mars. That's just, we have been shocked and just, you see the flights, right? It takes off and I almost feel the freedom that it feels, no longer tethered like Bob was describing with, test cables or stuck in a chamber, and I really feel Ingenuity loves Mars. And Perseverance, as I mentioned, has been the ultimate spoiler, just spoiling Ingenuity all this time. So that's how I really see it. And Ingenuity loves Mars.
Great, thank you. The ultimate Mars duo. Up next is Joey Roulette from The Verge.
Hey, thank you. Bill Harwood kind of asked my question, but I wanted to, expand a little bit. If things go really well in this new operational demonstration phase, are you guys hoping that you can transition or that it'll graduate again into some more operational capability, or what are you guys hoping for that? And how many flights are scheduled for that phase? Thanks.
Yeah, I'll go ahead and answer that. So initially, in the first 30 sols, we'll probably, after Flight 5, we'll get 1 or 2 flights, and then we'll evaluate. I think we are hoping that we can operate Ingenuity in a not-to-interfere basis with the science mission in a way that as long as it's available and alive, that we'll be able to continue in a way and learn more things, likely, again, as I mentioned, because Ingenuity is a tech demo helicopter that wasn't designed for a long mission. It wasn't designed with a hazard avoidance landing system. It wasn't necessarily designed to do an operational reconnaissance for a rover. But as we move forward, we'll evaluate how it's doing, and we would like to, on a not to interfere basis, as long as we can keep going with the sampling, we'd like to continue that if we can. But again, we're evaluating on 30 sol increments just to make sure we understand what's going on and how it's proceeding.
Okay, thank you. And up next, we have a question on social media. Jim on Facebook asks, are there plans to test max altitude possibilities? Bob?
Yeah, so right now we have found that the 5-meter altitude is a sweet spot for us to be. It gives us good resolution on the ground with our downward-facing nav camera. So when we do these map transects back and forth, it's a good place to be. We can see rocks and hazards and things, especially if you're picking a new landing site, that's good. But as part of this, providing utility to the rover, I wouldn't be surprised if at some particular location we are asked to go to a higher vantage point, like let's say 10 meters, and do a look around and provide some panoramic type imagery that might be useful to either the rover operators or the scientists. But for the normal sort of transect map making, the 5 meters altitude has proved to be a good place to be.
Thanks, Bob. And up next, we have Gina Sunseri from ABC News.
Mimi, as you watch Ingenuity fly, are you taking notes for a possible successor, what you would do differently?
Oh, yes. As we watch, the engineering data really has been examined and combed through by the entire team in the background. So absolutely on, what is the attitude and deviations from the predicted curves to the differences, those are being watched very carefully by our chief pilot, for our, the operations lead, and folks looking at the batteries and the temperatures. And so far, we haven't had to make any variations, but yes, our downlink procedure, downlink data review process is quite detailed, looking at many engineering products to examine the actual detailed health of the vehicle. But so far, we haven't had to make any adjustments.
And then up next is Steve Gorman from Reuters. Steve, can you hear us? All right, up next, we will try to get back to Steve, is Issam Ahmed from AFP.
Oh, hi. I think Steve was, should I just go ahead? Hello?
Hello, can you hear us?
Yes, I can hear you. Yeah, my question was off, so I'll ask a different one. I mean, how much, I understand you're going into a wait-and-see phase and seeing if you can sort of integrate these two missions together and have Ingenuity contribute to the science. But I was wondering how much of a factor is the sort of public excitement around Ingenuity in this decision? Because obviously it's a really cute image to imagine these two robots, you know, exploring Mars together. And is that actually a factor in your decision-making?
Laura, you can take
I can
that?
take I'll take the first part, which is that, you know, yes, Ingenuity is cute and it's fun and it's got an incredible public outreach, you know, capacity. But in all honesty, this is really based on the science of perseverance. And so what I'd really like for Ken to also add to this, because you know, we wouldn't even be talking about this if the science team hadn't made the decisions that they had. I mean, they're driving the show. Once we complete the 30 Sol technology demonstration, you know, we're you know, really serious business on getting down to the you know, preparations for taking those first samples in Jezero Crater. And so it was the science team that was really focused on the science they wanted to do, and when they established what their science plan was, realized that there was an enabling opportunity here. So I'd like Ken to expand on that if he can, please.
Yeah, sure. To repeat some things that we heard earlier, but to really drive home the point, the challenge that we foresaw originally with the helicopter and the science mission is that we thought we would be doing an intensive drive campaign in which the helicopter would not be able to keep up, literally because it needs to recharge between flights and because we have the ability to drive very quickly, we could get out of range. Based on the rocks that we have seen in the area, we really wish to spend a considerable amount of time where we are. And so it's sort of a fortuitous alignment of these two things. But it's also worth pointing out in maybe a more clear way, you know, Mimi talked about the support that she's gotten from the Perseverance rover and the Perseverance team. And that has come at the expense of being able to do full-blown science. And so now that we're moving into this additional demonstration phase, we really do have to see whether it is possible to carry out the science mission and support the helicopter simultaneously. And that's why we're going to do this operational demonstration test, just to see how it works.
Great, thank you. And up next, we have Chelsea Goad from space.com.
Hi, my question is for probably Mimi and Jennifer. You mentioned that with the ops demo, Ingenuity will likely fly one or more times than the 5 times slated for the tech demo. How many flights are you expecting for the ops demo? And if this addition will perhaps hinder in any way Perseverance's science mission, as we know, previously the tech demo had the rigid timeline because Perseverance had to go and begin its sampling mission. So it seems that that's changed quite a bit, and so I'm just curious what those expectations are.
Okay, yeah. So let me expand a little bit on the support that Perseverance provides for Ingenuity, and a few things I think I mentioned, but one I forgot to, that will make the support a little bit easier for Perseverance. One of the things that we are doing, so within the next 30 sols, within the extended or the ops demo 30 sols, I expect we would fly 1 or 2 times with the Ingenuity. What we aren't going to be doing anymore, which took an enormous amount of time, is imaging the helicopter flights. And that is what took away from our ability to continue with the science mission in one way or another. The other thing that we didn't do is move very far away from the helicopter, and we are going to move further away from the helicopter. In fact, the helicopter is moving further away from us on Flight 5 to go to a different location. And another thing that made it take more resources for the helicopter during the Ingenuity, the month of Ingenuity, was that we were not moving any mechanisms while we were communicating with the helicopter. And this could have been, you know, some sols it was 2 hours, some sols it was 1 hour to get all this data that we got back, which is very useful. We weren't moving mechanisms because we were concerned about interference. We have worked towards a demo in our test beds, and we're doing this on Mars to start to confirm that we actually can move mechanisms while we're communicating with the helicopter. And that would mean we can do imaging and things like that that are not just the single images of the helicopter, but we can do science while we're getting images back from the helicopter. I think things like that are things that we're hopeful will work, but we're cautiously optimistic because we have not done those things fully yet. And so that's why we're looking at this every 30 sols to make sure we can still do the full operation. And we did coddle Mimi, the helicopter, and now we're taking some of that away. And the helicopter will have, Ingenuity will have a different risk posture in how the mission proceeds.
You know, just to add to that, Jennifer, like one of the things we're doing with the helicopter going forward is helicopter has a built-in hardware capability to just wake up every day at a given time, like 12:30 p.m. local, Mars Standard Time. And if it doesn't hear from the base station, it'll just go back to sleep and then wake up again the next day. And so we don't have to be, there is a mode where we don't have to be talking to it every day like we have been. So that's an example of one of the slower cadence capabilities that we're going to be exercising on the helicopter in this phase for the first time.
Thank you. And it looks like we have Steve Gorman from Reuters back on the line.
Yeah, hi. Thanks for hanging in with me. I appreciate it. You can hear me okay?
We can hear you. Thanks, Steve.
Okay. So I had two quick questions. One, in the last news briefing, Mimi Aung was talking about how she was emphasizing how they really intend to push the limits and push the envelopes on this helicopter, really push it to its limits. So suggesting, I think in response to a question, that in the end, for the sake of engineering, that Ingenuity would probably not meet with a really happy ending, and like it might. They're really going to try to push this thing till it couldn't function anymore, like maybe crash or something. And it sounds to me like with this new operational demo that maybe you're not going to push it. You said there's going to be some natural pushing of its limits by sending out farther and farther afield and so forth. But maybe you're not going to be really as aggressively pushing this aircraft's limits as much as you can. Is that correct? And during the operational demo. And secondly, what are some of the kinds of features on locations that you might be sending Ingenuity out to fly to inspect in surveillance that the rover could not access in the next 30 days?
Do you want to take a cut at that, Bob? Okay. Yes, we will always be pushing Ingenuity, but you are absolutely right in detecting that Ingenuity surprised us. It really did. With from the first flight to the third flight that we've had, it's been so perfect that our mindset went from, what are the uncertainties, like what are the differences that we're seeing with the flight at Mars versus the models that we had in our hands. And in the press conference, our mindset was, okay, we're going to see differences and we're going to have to update our models, and let's be updating and pushing the envelope as we're having to update the models. And the beautiful surprise here has been our models have not had to be touched. And they project all the way to the future missions of larger vehicle that we dream of building. And so that's been the good news. And you're absolutely right in detecting that shift now. And it's become an opportunity, right? With the opportunistic Perseverance rover is going to be nearby, and we get this chance to try out operational demonstrations. So two things are going to happen. We are going to start getting these products that will really feed forward to future missions using aerial platforms. And as we do that, we are going to have to push the envelope because of the unsurveyed terrain and more difficult terrain that simply the rover cannot get to. And so that will naturally push the limit. But you're right. I think I made the comment, I was pushing Hobart Grip, who was sitting right here and saying, come on, we got to go at least 600 meters, 800 meters. Kind of pushing for the model's sake. We've backed off a little bit just because we've had no surprises in the model. But don't worry, we will be pushing the vehicle because we'll be using it in very unpredicted ways. So
I'd like to add to that. Even on Flight 4, we have pushed some of the capability. We are flying faster than we flew on the third flight. We are flying for longer than our original design limit. We absorb all the waste heat in our motors in the motor itself. And originally, we thought we would need to restrict that to about 1.5 minutes. Flight 4 is going to fly over 2 minutes on that motor, so we'll see how well that holds up. We're also currently, not optimized in our navigation system to fly over undulating terrains. We are sort of more of a flat plane, which is what the airfield and that flight zone was selected for. So we're going to be flying over terrain that will introduce a little bit more navigation error. We'll see how well that works. So it is being pushed, but it's being pushed, in a good way, in the sense that we know what the good performance has been, and we're pushing, cautiously, but it's still being pushed.
Thank you very much.
All right, and up next we have Jeff Faust from Space News.
Good morning. A question for the Ingenuity team, just to follow up on some of those earlier questions about pushing the limits of the helicopter. What sort of range do you expect to be able to get on these flights? How far downrange and back do you expect to go on some of these future flights beyond the 133 meters of Flight 4 today? Thanks.
I think total of about maybe 600 meters is not unreasonable. 2-minute flights at 5 meters per second is something that definitely is a possibility. That's probably where, we'll see how well it does on that one and see whether there's even more margin that we can, use for further flights. But that's probably a good place to think of a limit.
Thanks, Bob. And up next on the phone lines is John Wentz from Inverse.
Hi, I was just wondering what the transmission rate is between the helicopter and rover, and also, had you known this would be so successful, what kind of payload you might have wanted to be aboard the helicopter?
Well, we're transmitting data at about 100 kilobits per second, and we have 2 legs in that journey. One is from the helicopter to its base station, which is a radio link, and then there is another serial line between the base station that's mounted on the rover to the rover computer itself. And so it has to make those 2 hops. They're comparable speeds at what I indicated. And what was the second part of the question?
Have we known that?
Yeah, have you known that this was going to be as successful as it was? What kind of payloads, or what kind of payload do you anticipate for your next helicopter?
I can turn to my project manager. I had to fight to get the color camera onto the helicopter. So I'm very happy that we got that one little 1-gram payload. And we couldn't even call it a color science camera. We couldn't call it anything like that. We had to call it a return to Earth camera. So maybe Mimi wants to talk about payloads.
I confess, very focused, right? When we started this was about showing that we can fly a rotorcraft, right? We started with the question, we had a lot of people questioning, right? Very smart people. They said, really, is it possible? So yes, Bob, I confess, I was very obsessed with engineering data on how does a rotorcraft fly at Mars, right? Not just it flew, right? You can see it flying, but really getting the data back on how does it fly so that we can confirm our models. So yes, I was just obsessed with getting the engineering data back, and payloads, I admit, were in the back burner for me.
And Ken, would you like to contribute too?
Yeah. So I would suggest that the science team would love to see a capability that effectively takes the high-resolution cameras that we have on board the rover and puts them out over the landscape that we cannot drive to. And so the color images that we are getting there already are spectacular. We'll have to see if we can make out features that are of interest to the science team. But I think imagery is the key payload for this. For a future helicopter, is to produce high quality stereo imagery.
All right, thank you. And now we have a social media question coming in. Deanne on Facebook asks, how will this research impact human flight systems for Mars exploration in the future? Laura, would you like to take that?
Sure. So I think there's a lot of potential here, not just in supporting robotic missions, but an aerial platform can do the same types of reconnaissance things that we're going to test in this operational phase. We can do the same types of things to support a human mission. The ability to go and fly to locations that perhaps are too far or too difficult to traverse for the human explorers to get to. Using that aerial platform to collect data there, or to scope out the path for the most effective and efficient traverse for our human explorers or for their vehicles that they're using to move around on the surface. And so I think there's a lot of similarities there between the types of things we're going to demonstrate in this operational phase that'll feed forward not just to the robotic, but also to human exploration.
All right, thank you, Lori. And we're going back to the phone lines now. We have Irene Klotz from Aviation Week.
Thanks very much. For Bob, did I hear you correctly say that the maximum flight durations is now moving from 90 seconds to possibly 2 minutes? And for Lori, is there a cost associated with this mission extension? And realistically, how soon do you think it'll be before a science rotorcraft would be flying on Mars? Thanks.
Yeah, to answer, yes, even Flight 4 is going to fly 2 minutes, and that's where we're comfortable right now.
Yes, and of course, everything comes with some cost. Nothing is ever free, but this is going to be at a very reduced capacity for the operations for the Ingenuity helicopter. As you heard Jennifer say, we're talking about, the cadence that has been an every 3-day flight cadence to perhaps, every couple of weeks flying. And so this is a much reduced operational scenario for the helicopter. And again, with a very, moving to this focus phase for the rover on the science, very minimal, low impact on the rover as well. So, nothing comes for free, but it will be very, very minimal. As far as the timeline for when we could see this, we've got an amazing community of scientists in planetary science that come up with great ideas that get proposed through our proposal processes. I fully expect to see something the next time we have an opportunity to get some clever ideas there. And you just never know what the next opportunity might be. But I know we'll see it.
Thank you, Lori. And up next, we have Stephen Clark from Spaceflight Now.
Thank you, Stephen Clark, Spaceflight Now. Just to follow up on Irene's question for Lori Glaze, is there any capacity or margin on the Mars sample return mission to put any sort of rotorcraft on board, or is that not something you're considering right now? And also, my phone dropped out briefly, so I apologize if I missed this from Ken Farley, or Jennifer Trosper. But how soon do you think it'll be before you can take your first sample with Perseverance? Thank you.
So I'll take the first question there. The Mars sample return mission is a very, very ambitious mission requiring multiple launches from Earth, requiring spacecraft from both the United States and from European Space Agency. And so it's very, very ambitious as it is. So I think it's really important that mission stay very focused on its mission to collect those samples that are going to be collected by the Perseverance rover. And again, with that, there's not a lot of room to add additional things onto that mission. It's already got an incredible scope and an incredible tasking just to bring those samples back. So I don't expect to see any additional flight elements going along with sample return.
And I can take the second part of the question. So the laundry list of things I talked about we need to do will take us a few months. So we expect to get our first sample in July, in the summer.
Thanks for your answers. Up next, we have Leo Enright from Irish Television.
Thanks very much, Raquel. I wanted to ask Ken Farley about that magnificent panorama that he showed us in the context of the short to medium term science plan. Am I looking at this correctly when I think that the
The large outcrop in the middle of the picture is the Katmai outcrop, the delta remnant, putatively. Is that correct?
It's called Kodiak.
Sorry, again?
That is a delta remnant. Right in the almost dead center of the image is the delta remnant that we call Kodiak. And we've obtained some really spectacular images of that are up on our raw site already.
And if I could ask then, obviously your short-term target at the end of your ice cream scoop red drawing is obviously then that outcrop at the extreme left, which would be at the bottom of Big Bend. Do you think that might be a delta remnant, or are you ruling that out?
Yeah, this is a really good question. The end of this red zone here, the area that we will execute our campaign in, was intentionally drawn to allow the team that is going to create the campaign. That's the way we do it. We're going to task a small group of scientists to prepare a plan for what we might do within this red zone. They're going to be able to choose what we do. And the feature all the way in the southwest corner is a small, about a 10-meter high hill that we call Pilot Pinnacle. And it could be a delta remnant. It might be something else. It looks different than Kodiak. Just even in the high-rise images that we're looking at here, the orbital images, it looks different. So we're not really sure what that is. The most likely explanation is that it is a delta remnant, but it could also be something else. It could be a surprise.
Raquel, I had a follow-up if there's time.
Yes, there is.
Just for Jennifer, I was curious. You mentioned the microphone characterization test and some video that you shot. I'm just wondering, was that the mystery video on Sol 67 where absolutely nothing happened?
It could very well be. I'm not sure I am that familiar with the mystery video, but it could have been during that test, yes.
Thank you.
Great. Thanks, Leo. Work on getting you that answer. And up next, we have Rick Lovett from Cosmos Magazine.
Yes, thank you. My basic question is, so flights 4 and 5 are the extended mission for the first 30 days, or could there be a 6th?
Oh, the flight 4 and 5 we're transitioning into this operational demo phase. So we should view them as operational demo phase, and it is the first time we are flying ahead of the rover. Ingenuity is flying ahead of the rover, surveying a terrain that we haven't seen before and picking from it and transferring. And then from then on, for flight 5, Ingenuity will leave the current airfield, the Wright Brothers field, and Ingenuity will permanently transfer to the new airfield. So from there on, yes, the intention is for flight 6, and 7, so on, working together with Perseverance operations and science perspective to figure out, what operational products and scenarios that we want to explore.
Thanks. Well, I can follow up. That means there could be in this 30 days more than 2 flights. There could be 3 or 4.
Yes, we're looking every 2-3 week cadence.
Yeah, we'll do flights 4 and 5, and then we'll probably have 1 or 2 flights after that throughout May.
Thank you.
Up next on the phone lines is Ken Kramer from Space Up Close.
Thank you for taking my question, and congratulations on fantastic results so far. I'm wondering with the color camera, since you're going to stay aerial for a while, would it be possible to do stereo imaging with that? One of you just mentioned that a little bit, taking stereo images. If you can keep it up, turn it a little bit, is that possible? And can you get any science at all out of that color camera? Thanks.
Yeah, I can take that. Yes, so we can do stereo, and it was considered as a possible, demonstration. It's just that we have a little bit of our timing on scheduling the color camera on the helicopter is not as precise and as carefully controlled as we can do with the navigation camera. And since the flight force objective is really to find the new landing field, the nadir-pointed black and white camera will seem to be better for that. But yes, at some future point in time, we can definitely do wide baseline stereo imaging using our color camera.
Thank you. And we also have some social media questions coming in. Fred on Facebook asks, are you going to make a map out of Ingenuity's pictures?
So I can take that too. Yes, there is actually a mapping team that works closely with all the Perseverance images. Everything that they do, there is a whole pipeline of processing which results in map-type products that come out of the other end. And we have been feeding our images from our cameras to that same team. And they have been building up, and they're getting ready, in fact, to build this digital elevation map, which is that first product from this long transect. And there are other map products that they can do. They have the good models of both our cameras. So as long as they get their images, which we hand on to them, they can process it, and they will prioritize how they process it depending upon what the need is.
Thanks. Another social media question. That Guy Crafter on Twitter asks, will the data from Ingenuity be useful for the Dragonfly mission on Titan, or are the environments too different for it to be relevant? Lori?
Sure. So I'm sure that Bob and Mimi can also say, but the teams have already started talking to each other. And yes, the environments are very different, but we are talking about remotely operating a rotorcraft in another environment. And so I think there's a lot of information that can feed forward about how we're operating this rotorcraft on Mars that can be helpful to the Dragonfly team as they develop their rotorcraft, which of course will fly on Titan. As I said, I believe the teams are already speaking to each other about how they can how the Dragonfly team can build on what has been learned from Ingenuity.
You want to weigh in too, Mimi or Bob?
Oh, okay, yeah. So one aspect, I think, Bob and I, in our journey going from inventing the helicopter, in parallel, we found ourselves inventing the verification and validation approach. How do you test a rotorcraft that's going to fly on another planetary target, right? How do you test on Earth? And that itself has been a journey. So, for example, that is one area that we can really contribute to future aerial vehicles for other planetary targets. And yes, we are in communication. In fact, Michael Rixkevich was our independent review chair for the Ingenuity's entire development phase. So definitely connected. And the second aspect that Ingenuity can contribute to future aerial platform missions is how to operate it, right? At these large distances, how do we operate it from Earth? And that's also a very highly valuable information. And then, of course, with the latest now, the opportunity that we're getting in the operational demonstration phase, now we can go a step further. We will be looking at potential use cases and potential products that can really help operations as well as science exploration aspects of it. And we're very proud to be able to help future missions that way.
Thank you. Another question coming in from Twitter. Kumar asks, how long, theoretically, can it stay afloat in the air with its batteries fully charged by the solar panels? Assume they're talking about Ingenuity here.
Yeah, so our constraint is not the energy in the battery. We actually reserve most of the energy for staying warm through the night. The constraint really is a thermal constraint on how long we can operate the motors. Since we were a technology demonstration designed for short flights, all the waste heat in the motor actually gets absorbed in the motor, and the motor temperature rises by about 1 degree centigrade per every second of operation. So we have to manage that, and that's the ultimate limit that keeps us, puts a constraint on the time. It's not so much the energy in the battery. We have plenty of energy that if we wanted to fly longer, but it's purely a thermal temperature constraint.
Thanks. And then Arno on YouTube asks, how excited are you guys on a scale from 1 to 10 now that Ingenuity will keep flying?
10.5.
I don't know. I think I saw Mimi jump up and down the chair when Ingenuity flew that first time, and I'm not quite sure I can quite get that energy level, but it's been awesome. It's been awesome. So I don't want to put a number to it.
Sounds like it's off the charts for you, Mimi. And then our final social media question, Charles on Facebook asks, the human race at its best when it is trying to achieve the impossible. How can the public help NASA continue this endeavor?
That's a great question. You know, part of what we do with everything we're doing in NASA is to inspire. You know, we want to learn, we want to understand within Planetary, we want to understand the solar system and all of the planets and bodies that make up our solar system. But then we want to take that learning and what we've learned and inspire the public and everyone around. And so I think from the public side, the support of everything that we're doing, the incredible support we've seen from the public of both Perseverance and Ingenuity has just been absolutely wonderful. We're just so thankful and so happy that we can take the whole world with us, along with us on this incredible journey to explore Jezero Crater.
Great, thank you so much. Now, if members of the media have additional questions, please call JPL's Digital News and Media Office. We'll also continue to answer social media questions online. Thank you for all your questions, and thank you to our panelists for joining us today. To learn more about the Ingenuity helicopter, visit go.nasa.gov/Ingenuity. To learn more about the Perseverance rover, visit mars.nasa.gov/Perseverance. There you can also see the latest images coming down from the rover. And if you're on social media, join the conversation about the helicopter by following @NASAJPL and use the hashtag #MarsHelicopter. You can join the conversation about the rover by following @NASAPersevere. Thanks for watching.